Hey there, guys, it's Mr. Sheline. This is going to be the video that's going to be, or I guess the second video that's going to be helping you out when it comes to using a graphing calculator in order to complete multiplication and division problems using a graphing calculator. Um, so the other video I had, I was a bit worried that maybe you really couldn't see anything, that it was a bit too dark, or it was just everything's a bit too small. So here, what I'm going to do is I'm going to provide kind of an alternate type of presentation to maybe help really solidify what I'm doing with a calculator in order to solve these problems the best way that I can on here. So what I'm going to do is I'm going to quickly just kind of go through and talk about these three different types of calculators that you most likely have and are using for my class and other classes in order to complete math problems. Then what I'm going to do is I'm going to do some practice problems, and I'm going to do some screen capture with my actual calculator that I've got plugged into my Chromebook right now, and we'll see how that goes. Okay, so real quick, just looking at these three calculators, these are the three that are most likely the ones that you have probably been using or will be using going forward. These are the typical graphing calculators seen in high schools today. You've got two here that are the TI-84s from Texas Instruments, and then one from Casio that is pretty much on par with the Center TI-84 plus CE seen in the center. So what I want to do is just kind of show the layout of these calculators because they are pretty similar but still kind of different at the same time. And I just want to highlight the buttons that we're mostly going to be using on these guys or when we're putting our math problems together, specifically for scientific notation math problems. So the guys that we're going to be mostly using. So if you see my mouse here, which I don't know why I'm not seeing. That's not the button I want to press. Sorry about that. Alt-T. That's still not it. Come on, man. There's the toolbar. Okay. So and it's not showing. I wanted to just to make my, I guess what I wanted to do is make my mouse that much more noticeable. So that's kind of strange. So anyway, sorry about that. But these are the buttons that I really want to highlight that we're going to be using like mad, like crazy, that I mentioned in the other video. And here I can get maybe a better, clear picture of the ones that we're going to use. So the ones that we're going to be using here are going to be mainly, we're going to be using these arrow keys right here, or this arrow key, I should say. This is our exponent button. Okay, that's what I'm just going to say it is. So this is the button that we're going to be using in order to quickly plug in an exponent in a problem. Okay, so that's the one I mentioned the other day. More or less, this pushes your key, your cursor on your graphing calculator into the subscript position in order to plug in numbers that will then function as exponents. Okay, so we're going to be using that button like crazy. We're going to be using, obviously, the times button like crazy. Okay, and you can find the times button right here, which we all should know. Here's all the different times buttons, multiplication button. Here is the negative key. Okay, so the negative key on our calculators, pretty much all the same. And then our enter key, of course, because you can't have a solution to a math problem you plug in without hitting the enter key. And actually, I'm not 100% sure. I would imagine this is our enter key. I'm not 100%, but I would imagine since it's in the same spot it is for the Casio. Okay, the other big ones here, and these are going to be the most important, arguably, are the parentheses keys. Okay, because again, we're going to be using these guys like crazy, like you can't believe. And then finally, it's going to be our arrow keys here, because you have to make sure that you punch in these arrow keys, specifically the one to the right arrow key. You need to punch those in, or else remember, if you punch in the next thing, it's going to leave it as an exponent, and you got to say, nope, I need to go over. And then one that I mentioned in the video, that E key, the shortcut to where instead of having to put times 10, there is the E key. And in order to do that, you've got to do this. So I'm going to put this one in red, just to signify that you have to hit shift. So you hit the second button here, and then you've got to hit on the TI-84, you hit this guy, because what you're wanting is that double E, that blue double E up there. And then it's the same thing on the Silver Edition. Okay, the button with the comma on it, because it's got that double E. And then on the Casio, it's pretty much the same thing. You hit Shift, and let's see, now I got to find it. I just saw it. Where'd it go? There is this, I think actually that is the equivalent. Yeah. And the equivalent is here on this key here, because you're going to go for the E with the exponent, the X up top. But it also looks like you can also hit this right here. You can hit the log key, Shift, and then the log key to get your 10 and then X over here. So that's probably an option as well. Something to play around with, because again, I don't have this calculator, and I'm just going off of what I see and what most likely makes sense. And I guess to show that too, there are the same keys here on the Texas Instrument, the TI-84. So you can see here on these keys that you do have the 10X and then the E superscript X as well. Figure out whatever works best for you, as long as it's correct. As long as it, whatever you're already in the habit of doing. Personally, I like putting in ×10 and then this up arrow key right here that we've been using. I'm a bigger fan of that, because once you plug it in on your calculator, it'll look exactly like it is that you have written down, what is already, on a piece of paper. So I just prefer that, because, when I have to go back and look at it, it makes sense to me. Okay. So that's the lowdown on these 3 calculators, which you probably already knew. But just in case, this is just in case that you forgot, or this is, you're still new to this and you're needing to know, well, I don't know where these are. Here they are. And we need to really start getting into the habit of putting these in. And then real quick, because I'll just talk about the TI-84, because I don't know about this with the Casio, though I can maybe see how it's used. Other keys that we use a whole lot as well that you'll see me use, I'll be using the delete key all the time. And not only that, there is also the insert button as well. So the insert button is also a handy dandy little guy, and it's right there above the delete button. The insert key, where you more or less use your D-pad, you're using your arrow keys here to maneuver through your mathematical sentence, your operations, and then you can hit second or shift, insert, and then you're free to plop in whatever you need to, in the middle of your expression. And then the same thing over here on the Casio. I would imagine this is the same thing, because just by spelling, you do hit shift, and it looks like you have to hit INS here on their delete button, which is right here next to the on button and delete button. Well, not the delete, but the clear button. Okay. So that's it that I'll talk about as far as those are concerned. So let's just try to get, let's do some examples here on using the calculator. Now, again, because this is something that I'm doing on the fly, I'm gonna try to use these screen captures in order to kind of get to show you what it should look like on the calculator when you're plugging these in. Okay, so we're just going to go here, and we're going to start with number 1. So it looks like it's going to be 8.18 times 10 to the negative 6th power times 1.15 times 10 to the negative 5th power. So I'm going to plot that into my calculator, and I'm going to make it look exactly how they have it. So parentheses, 818, and then times 10 to the negative 6th power. And I know you can't see what I'm plopping in, because, again, it can only capture like a screenshot. So just bear with me here. And I hit the arrow key, lock it in, and then I hit the times button, new parentheses, 1.15 times 10 to the negative 5th power, arrow key, and parentheses. And this is what I have on my calculator that you should also have if you're following along here. So this is what I have exactly on my calculator using the keys that I just talked about. Now, I could also do this. So remember, there is also this option. So I'll put 1.18. I'm going to hit a double E key. Okay, I hit second, and then I hit the comma key, because there's that double E when I hit shift. And then I'm going to put negative 6, close parentheses, times new parentheses 1.15 times, and then the e, and then -5. And then I'm going to have this. I'm going to have this looking thing here. Okay. So that's going to be literally the same thing as what I had before. And you'll see that, and I'll show you here. Oops, because I didn't do that. And I'll show you here that we'll get the same exact answers no matter what. Okay. Oop, and I need to just replug it in, it looks like. So give me a second here. So times 10 to the -6th power times 1.15 times 10 to the -5th power. Okay, and I'll take a screen capture of that, and you'll see here that I get exactly the same answer, okay? So this is a great way to double check to make sure what you're putting in is correct. You know, here are two manners in which you can put it in. Again, I very much prefer the second option that I have in the screen capture and this little guy right here, because again, it looks exactly like it does in the worksheet. So if you have to go back, if you have to double check your work, you're not confused by what you're seeing. It looks exactly what it looks like on the piece of paper. Because if you go back and look at this guy, you're like, wait, you know, in that split second, you may be having to waste a couple minutes trying to figure out what it is that went wrong. And you forgot that, oh, yeah, this -6, that's an exponent. Because I forgot the E tells us that's an exponent. Or here, you just quickly look at it, it's times 10, and then you've got the -6 in the superscript. You know immediately it's an exponent, and you know exactly where everything's at, what they're representing, and what they're supposed to do. Where again, here you may take a minute to realize, oh yeah, I forgot that, yada yada yada. So anyway, okay. Another thing that you have to remember here is that you have to also keep sig fig. So always keep that in mind, that as we're doing scientific notation and as we go forward, as we move forward, unless I tell you that you don't need things in sig figs, then you need to have them in sig figs. So in this case, if I were to ask you to give me the correct answer here, the correct answer is not the 9.4007. It would be 9.41. And then I'll just keep the way that how they plot out the answer. And then this is what you should actually have, and I'll keep everything together here, and it'll be what I entered in. So it would be actually 9.41, then the E, or times 10 to the -11th, okay, power. That would be your actual correct answer, because the number of sig figs that you have here is 3. So you have to make sure you keep along with that. So just keep that in mind. Okay, let's try a division problem. So, and I like these division problems, the way that they have these in the on the paper, because for the most part, this is what they're going to look like when we get into STOIC, when we get into what's the word? I'm losing my words here. Dimensional analysis. Everything's going to be, you know, as a fraction with a fraction bar with your denominator, or with your numerator and your denominator respectively. So this is what it's going to look like more than anything, and something to prepare yourself for, because we're going to be doing a whole lot of dimensional analysis until more or less April. So just prepare yourself for that, and they're going to look like they do for these guys here, like 7 through 12. So nothing to be spooked of when we're working with something like this. You know, it's just division. So we're literally plotting in the same thing. It's just instead of multiplication, it's division. So let's take a look at number 7 here. So 7.8 times 10 to the 4th power, close parentheses, divided by 8 times 10 to the 1st power. Okay, so here's what I've got. Okay, and then I'm going to hit enter, and then this is what I got as a solution. And so this is a good example here to talk about, you know, do we keep scientific notation? Do we not keep scientific notation? Because that's a good question that I had a lot of students ask me last year, and I'll just say that if if your number is getting past, I'd say like 10,000, that's when you really need to have scientific, and this is specifically if I don't, or if I don't explicitly say your answers need to be in scientific notation. And this is something we'll talk more about when we get to that, but just a note now. If I don't explicitly tell you to put all your answers in scientific notation, typically I'm fine with you putting, or most times I'm fine with you putting in scientific notation. It's more appropriate when you get past, like, say 10,000. If your value is past 10,000, that's when it's like, okay, this is a lot of values in this one, set. And especially if you only have, like, say 3 sig figs, maybe we can cut this down into scientific notation. Now, if you were to give it to me in scientific notation and you have the correct number of sig figs, would I say it's wrong? No, it'd be 100% correct. Just you did a little bit more work than you needed to. So the idea that I'm getting at here is that, okay, you plot this in, you get the answer, and it's 975. What do you do with that? Do you keep in scientific notation or not? Again, if I explicitly tell you to, this should be in scientific notation. And so what that would be 9.75 times 10 to the, in this case, just second power. So what you'd be looking at here is, and I guess I don't have to keep deleting these, I just realized that. So you would have something that would look like this, 9.75 times 10 to the second power. That's what you would have. So again, if I explicitly directly tell you that, you need to have them in scientific notation, I expect them to be in scientific notation like this. If I don't, use your best judgment. If you're going past 10,000, it should be in scientific notation. There's no reason to write all those zeros. It's kind of silly. It's more work on you. Just cut it down. But if it's 975 and I don't tell you that you have to have in scientific notation, it's fine to keep it at 975. But that's going to be when we get further down in Unit 5 where that's really going to matter. Not so much here, because I'm telling you, keep it in scientific notation and give me an answer in scientific notation here. So what else? Oh, I can go in and show you a little bit easier, a little bit better what to do if you want to have your answer in scientific notation automatically. Now, again, like I said in the other video, I don't recommend this specifically because it doesn't always give you the correct, or it does give you the correct answer, just it doesn't keep sig figs, which there is a sig figs function in here. I don't want to give that to you just because we're practicing it for the most part. But in this, because it can save some time, but again, I don't recommend it because it doesn't give it to you in sig figs. There is an option in order to set your calculator to give you the answer in sig figs. So what you do, and I'm going to go to my presentation here, my little slideshow, to show you on the calculator. So on the calculator that I use, what I do is I hit this button right here. I hit the mode button. And when I hit the mode button, it's going to take me to a page that looks like this. Okay, it's going to take me to this page right here. Okay, and when you go to this page, it's the second option right here where it says normal. You want to go over here to psi. Okay, you go over here to psi, you hit enter. And so what it does then is that it plots all of your answers in scientific notation. So if I were to then do the same problem here, now it will give me an answer in scientific notation. Okay, so there it is. It gives it to me in scientific notation, which again can be fine. It's just it doesn't keep sig figs here. Okay, and there are times when you may be really confused why it changes the exponent, and I just want you to be super careful of that. And sometimes where it'll put your answer in scientific notation when it really doesn't need to be. So just be careful with this. and technically, arguably, right now you can see here, and actually something I just messed up on, is that actually all of our answers so far have actually been incorrect. So now, to really nail that idea, that answer would be incorrect because the number of sig figs that we have, or that our answer should be, is just one sig fig, because 8 times 10 to the first power is one sig fig. So this answer actually should be 1,000. So if you were to give me this answer, it'd be wrong. And you spend all this time and work and hassle and having to change the scientific notation for nothing. So again, I don't really recommend it. Because and there's a lot of calculations that we do that you don't want to have in SigFig, or sorry, in scientific notation. That you'll be bouncing back and forth, turning on and off your mode from normal to scientific notation, and that's just silly. Okay, so I'm going to change mine back to normal. Now, if you have experience with this and you're fine with that hassle, that's on you. I highly recommend that you don't do it. Just do it the most basic way, even if it does take a little bit more time in some ways. I highly recommend it because it to me, there's less that can go wrong because you're actively thinking about what's happening rather than just relying on a calculator plotting out the answer for you, okay? Which is a big distinction. You just want to be careful. You want to rely upon your own abilities rather than just completely relying upon a computer to do everything, every little thing for you. Because a lot of times, it's not that the computer is completely wrong. It's just that, it relies upon the input that a human puts in. So because we're fallible, because of the fact that humans make mistakes, you could be putting in that answer and something's wrong in that, or you can, put in the problem. And you may think it's correct, but the calculator is just a computer. It's going to put in what you put. It's going to put out what you put in. So if you put something in incorrect, it's going to give you something back that's incorrect. So just be careful there. It's only as good as what you put in it, and that's why I really don't recommend the scientific notation portion. But again, if you're used to it, go for it. Just make sure that everything's correct on your homework assignments. Okay, trying to think if there's anything else. This is, again, just another demonstration to show you guys, and hopefully this is a little bit better in that kind of sense, on how to do this. What I wanted to do is have, Khan Academy has the actual calculator interface on the computer. I tried looking for one of those that matched with my TI-84 and other the Casios, and I just couldn't find them for my Chromebook. So if you guys do know where that's at, I'd really appreciate you guys letting me know. But that's what was preferable, but I just couldn't find it. So this is the best that I could do. So anyway, this is a real quick kind of a little crude of a way to put together how it is that we use calculators to solve with scientific notation. I hope this video and the other video that I made helps. If you still have any questions, remember, I have office hours on Tuesdays and Thursdays. You can email me. You can get a hold of me on Google Classroom, whatever it is that you need. Get a hold of me, ask. We could put up a Zoom meeting, a Google Meet, whatever you need in order to really, really hammer in these skills, because your calculator is going to be, it's its own kind of skill, because you're speaking a whole different language on a whole different kind of computer, right? And it takes practice and it takes getting used to punching in, mathematical equations, mathematical problems, and you just don't do it, overnight. It takes a lot of practice and it takes a lot of revision. It takes a lot of effort. So anyway, so that is the video. Again, if you have any questions, please get a hold of me. Okay. So anyway, that's the video, guys. So I appreciate you watching my video. And I will see you guys all in the next one.